we can obtain a second derivative for a parametric curve in a similar way that we obtained the first derivative using the chain rule. So if we set the first derivative as y dash, then the second derivative of y with respect to x is equal to the derivative of y dash with respect to the parameter t multiplied by dt dx. So dy dash dt is basically the derivative of the first derivative with respect to the parameter t. And therefore, this can be written as dy dash dt over dx dt. And the second derivative tells us whether a point on a parametric curve is an inflection point, or whether the curve is concave up and concave down at that particular point. Given these parametric equations, derive an expression for the second derivative. So recall that the first derivative dy dx is equal to dy dt on dx dt. So that gives minus cosine t on sine t. And following a similar trend using the chain rule, the second derivative is dy dash dt on dx dt. So using the quotient rule, we have minus sine squared t minus cosine squared t over sine squared t. And then dividing through by dx dt, which is minus 2 sine t. That's going to give you minus a half cosec cubed t.